All right, it is time for us to get the ball rolling with Object-Oriented Programming 2, and we're going to do so first with a close look at constructors. Now, constructors are not going to be completely new to you, and I say that because in Object-Oriented Programming 1, we just had to use a constructor here and there in our examples to facilitate the setting of an object state when the object was created. So we needed them. But we hadn't yet taught constructors, and at that point I had told you, just relax. If what we're doing doesn't make sense, which for the most part I'm sure it did, because it really is a straightforward idea when using a constructor. But I said relax. We were going to get to it when we got into Object-Oriented Programming 2, and at that time we would take a look at it in detail. Well, here we are. So it is time to look at constructors inside and out. So by the end of this video, I've got about 8-9 different things that I want you to understand, and with an understanding of all of these things, you will have a very good grasp of constructors. Now, this was very tricky putting this section of videos together. And I say that because the question really came down to what went first. We had constructors. We've got static members, and we have inheritance. So the big question was, which of these videos do we present first? Which one second? Which one third? You know, having a good understanding of constructors allow you to demonstrate static members just a little bit better. But we have static constructors that are designed to work with static members. And then constructors work in a very particular kind of way, and to truly understand how they work, you've got to understand inheritance. So Logan and I were really caught in an interesting situation with, all right, which one of these things do we want to teach first? So we have decided to present constructors. Now, I am telling you all of this because I want you to keep this in mind as we are working our way through this video. You know, we're going to probably hear the word inheritance once or twice, and we're definitely going to hear the word static a couple of times. The bottom line is it's one of those scenarios of what comes first, the chicken or the egg, and we just had to say, all right, it makes the most sense to introduce constructors first so that we can then harp on them later when we're in static members, and especially when we get into inheritance. But we could have rolled this around in any way. Don't you agree, Logan?
Right. Though I agree with putting forth the idea of constructors first. That way when we get into the extended considerations of constructors, when we get into static members and inheritance, we've already got the idea kind of nailed down. So that way we just build upon that with static members and inheritance.
Exactly. So with constructors, like I said, bunch of things that we need to learn in this video. What are they? Let's go ahead and jot them down so that I can check them off as we're running through the video. First thing, of course, is going to be, what are constructors? So just jot this down. You know, they could have come up with a smaller name. That's a lot to write out. All right, once we have an understanding of what constructors are, the next thing we need to understand is the syntax. Obviously, knowing the syntax is important because we're going to, well, need to write our own. And without understanding the syntax, how can we possibly write our own constructors? From there, it's time to get a bit more specific. Let's take a look at the types of constructors. That's right, constructors come in different forms. So types of constructors. Now, even though I'm going to write the different types down right here, when we start getting into this, Logan, as we go more and more into this video, what we're going to do is probably focus for a great while on instance constructors, which is the first of two types. Let's go ahead and throw that down. So with all of the other things I'm about to write down in just a second, we're going to focus on all of those aspects through instance constructors. And then we'll turn around and talk about private and static. Ooh, private and static? That's right. But first, let me tell you this. Technically, there are only two types of constructors: instance constructors and static constructors. And quickly, by the term instance and static, you should have some sort of mental picture as to what I'm talking about. We know that when dealing with an instance of a class, we're dealing with an object. So when we hear the word instance, we should think of one or more, generally many, like many objects. When we hear the word static, we're talking about belonging to the class. We're talking about one. And that's exactly what's going on here. A static constructor, meaning it belongs to the class, or an instance constructor, and that's going to be available through each of our different instantiations of the class, or each of our objects. But we'll look at that closely. But like I said, technically, two types of constructors, instance constructors, static constructors. But depending on what book you read or what website you read, you are going to find that some authors are going to tell you that there are three types of constructors. And they are instance constructors, private constructors, and static constructors. So let me go ahead and take just a second and jot that down. So instance, private, and static. Now, a private constructor is an instance constructor, but it is a very special instance constructor in that it works in a very particular way. It's different than what you get from your regular public type instance constructor. So because of that, a lot of authors like to say that there are three types of constructors. And in this particular case, as long as you understand that technically there are only two, instance and static, I think it's fair for me to go ahead and present all three, though, so that you guys have a clear understanding of the advantages of using all three of these constructor types. So, like I said, here they are. We're going to talk about all of them through this video, but as we start to get into specifics, we're going to start off by focusing just on the instance constructor. So the next thing that we're going to need to learn how to do is how to pass parameters to the constructor. So it's going to be passing parameters. To constructor. This is very important. The primary objective of a constructor is to initialize the state of an object. That means when creating an object, you're generally going to pass the constructor some information, and that constructor is going to utilize that information for establishing the state of the object. This is exactly what we had to use it for previously in some of the examples that we created. So, well, that means we're going to have to understand how to pass information to it. With that, we're going to move on from there and start talking about constructor overloading. Constructor overloading. Now, you guys are familiar with method overloading. We've already taken a look at it. Method overloading is when you have two or more methods within the same scope having different signatures. So they have different parameter lists. Now, constructors are the same way. You can have two constructors that have different formal parameter lists. And we're going to talk about that here with constructor overloading. And with that, that'll quickly lead us into a conversation of initializers. So constructor initializers. Constructor initializers will let us basically chain constructors together. So from one constructor, you can call another constructor and pass information to it. And this is where things really start to get interesting. But again, this is where we run into a brick wall too, because without inheritance, we can't follow this through to its fullest of glory, though we will be doing that when we get into the inheritance video. So after we've taken a look at this, we're just going to take a brief moment and talk about the other modifiers. Because as we work our way through this, we're all familiar with modifiers by now. We have talked about them and talked about them. We're going to be using public modifiers. But obviously, in demonstrating a private constructor, we're going to use a private modifier. And in demonstrating a static constructor, we'll be utilizing the static keyword to demonstrate a static constructor. So you'll have seen most of them. There are a few left. Again, protected gets into an inheritance situation. We'll mention it, but it's not something we can really demonstrate until you guys have a good grasp on how inheritance works. But I do want to point out the modifiers. So with that, I think that's going to cover everything that we really need to look at. What do you think, Logan? If they understand all of these things, what do we have? 1, 2, 3, 4, 5, 6, 7 things that they should have a good grasp on constructors?
Then yeah, that should make a pretty solid foundation.
Sounds fantastic. All right, well, let's go ahead and begin with the most simple of them all. What are constructors? Constructors are special class methods. Okay, so they look like a method, but they're special class methods that are executed when the class is instantiated or loading, depending on the type of constructor used. This is very important. You hear me say that it is executed when the class is instantiated, meaning when we're making an object, when we're using that new keyword. Well, what happens if it's a static class? And with static classes, as I have mentioned previously, we cannot instantiate the class. So in that particular case, what happens to the class? Well, we have seen in some of the past examples where I've drawn out the stack and the heap. With a static class, well, the class itself, the type object, ends up on the heap. So basically, when the class gets loaded onto the heap, then we can basically execute at that particular point static constructors. Okay, so I'm just trying to make the point of that a constructor is not only when a class is instantiated. They also apply for static classes, which cannot be instantiated. So, the primary use, as I said a few minutes ago, of a constructor is to initialize an object. It's to set the state of an object. So, keep that in mind. It's very important. That is, what, Logan? 100% of the reason they'll always see us use a constructor? Can you think of any other reason that we'll be using a constructor where we're not setting up the object?
No, it's always going to have something to do with setting the state of the object. Because, I mean, any behaviors that are called from the constructor, the idea is that the constructor gets called whenever you have the object loaded or created.
That's right.
So usually that's why you would have that. To do things on load or create would be to set that object up.
Exactly. Okay, now let's throw out some rules. So guys, again, this is one of those areas where I just feel like talking a lot. And let me draw a line right here. And since I feel like talking a lot, you are more than welcome to grab that track bar and fast forward me past all of this writing so you can see the end. You can say, oh, okay, well, there's all the rules that he wanted to jot down. But here are some notes about constructors. I want to jot these down. First of all, the constructor name is always same as the class name. That's right. If we have a class called GameItem and we create a constructor inside of it, the constructor will be called GameItem. Now, we can have multiple GameItem methods, meaning multiple constructors, and they just all need to take in different arguments. But just keep that in mind. The name is always the same as the class name. That is a rule. The constructors do not return data. This is really the big thing that sets them apart from a regular method. With a regular method, you go in there and you say, all right, what's the return type? It's a public void update, right? And then we could say it's going to take some data in. Well, a constructor, you can't do that. A constructor doesn't return information back, so you don't set it up with like it can return an integer back or it can return a whatever back. What does a constructor return back? Well, you could say the address or the reference
of that class.
That's right.
And another way to look at it is a constructor belongs to a class. That means there's nothing else, there's nothing other than that class that it could return that would be relevant. Otherwise, it would just be a normal method.
That's right.
The only thing that constructor is going to deal with is the class that it resides in. That's also why it has the same name as that class.
That's right. Now, another one that's very important. With constructors, there is always... Let me underline that. It's so important. There's always a constructor in a class. How's that possible? Well, it's pretty simple, actually. If you do not specify a constructor in a class, when you build your solution, the compiler goes, hey, what you know? Logan did not put a constructor in this class. So the compiler puts a default constructor in the class at build time. There's always a constructor in the class. Keep that in mind. That's very important. That can actually bite you the moment you start relying on both a default constructor and suddenly a constructor that takes data in, but you're in a situation later in code where you may create the object or want to create the object through a default constructor, meaning you want to create it without passing data to it. Then all of a sudden, it breaks. But earlier, it didn't break because the compiler was putting one in. Well, the compiler, if the compiler sees Logan putting a constructor in, the compiler is going to go, I'm not going to add, there's no reason to add a default constructor because, well, he's explicitly defined one. So that's very important, and we're going to demonstrate that. I think that's important to see how you can get yourself bit in that particular situation. So let's see, what else do we have? Constructors. Oh, this is a really big one. Constructors are not inherited. Now, while we have yet to go over the inheritance lecture, we have taken a sneak peek at inheritance. Okay, we've had to do that back in the Object-Oriented Programming 1 section. Now, when talking about inheritance, we had shown you previously, as a quick sneak peek, that basically methods defined in a base class are, and if they're public or protected, become inherited with our extended classes, a class that, or the derived class, the class that is extending the base class. Now, in the case of a constructor, it is not inherited. It does not suddenly appear as if it belongs to the new extended class. It does not work that way. A constructor belongs to a particular class, period. End of story. It's not inherited. Okay? So those are some key things that you need to keep in mind about constructors. The name is always the same as the class name. They do not return data. There is always a constructor in a class. Always. If you don't define one, the compiler will put one there. And finally, they are not inherited. But guess what? The rules don't end there. They go even further depending on the type of constructor you're using. So we'll get to that in just a minute. What I'd like to do now is take a look at syntax. So let's see. We've got all sorts of stuff going on here. I'm going to bring up another sheet that we can start throwing syntax and some examples on. So let's go ahead and just come in here and add one of these. We'll hide this temporarily. And let's write out some syntax. So we'll start out with, and again, this is our simplified syntax. We're going to have modifiers. We're going to have an identifier. And then we're going to have our formal parameter list. I'll just write parameter list. Now it's going to get interesting. And then optionally, colon, we have our initializer. And then, of course, we're going to have an open curly brace. And then inside here is going to be the constructor body. And then finally a closing curly brace at the end. Now, with initializers, let's add to the syntax here. You're going to have one or two things. You're going to have rather base, so it'll be colon base. And then inside here, we'll have any arguments that are required by the constructor we're calling. Don't worry, we'll go over this here soon. So I'll just say arg list. So arguments. Or you're going to have this. And you're going to have a pretty good understanding of the this keyword by the end of this video, though we will have a specific video. It'll be a short one at the, or close to, the end of the Object-Oriented Programming 2 video section. So this same thing, this is going to be an argument list within opening and closing parentheses. Okay, very cool. So that is our syntax. If you think about it, it looks just like a method subtract the return type. Notice how there is no return type here. All right. So now that we know the basic syntax, it's time for us to get in there and start making some stuff. Let's go ahead and begin our focus with, in fact, I'm going to pull this down just a little bit to give me some more room. Let's begin our focus with instance constructors. And my attempt to draw a line, not too horrible. Our instance constructors are used to create and initialize instances. Every time you create a new object, the class constructor gets called. Every time, period. Now, Static classes cannot have instance constructors. And think about it. Come on. That makes sense. A static class cannot be instantiated. It's the whole idea. There's only one of those classes. It gets loaded up on the heap, and you access the class by accessing through the class identifier. You cannot instantiate it, so it cannot have an instanced constructor. All right, so let's see what one of these guys look like. Let's say that I was going to create a class. And we'll stick with game item since we've used it so much. And inside game item class, I need a constructor. So public. And now what was the rule? The name of the constructor is always the same as the name of the class. Now, following the syntax here at the top of the whiteboard, next thing, so we've got a modifier. Next thing is going to be my identifier, which is going to simply be game item. And then open and closing parentheses because those are required. It is only the parameter list inside them that is optional. You'll notice the square brackets are within the opening and closing parentheses. Finally, I'm not going to use an initializer in this particular case, so at this point we're just going to treat it like a method. Open, close, and then we'll just kill the class off. And then here we could simply say, write out, something along the lines of game item created. Yeah. So now all we have to do at some other point in code, like up in main or whatever, is simply say create a variable. So game item, we'll call it player, equals new game item. That's all we do. New game item. But in fact, I wasn't going to do this, but let me write that down. So let's say I had game item player equals the keyword new, and this is where I decided to go ahead and write this down. Check this out. Game item open, close, terminate. Check it out. It is a call to the constructor. Isn't it, Logan?
Yeah, because that's exactly what you're doing. When you instantiate that game item by calling new game item, that's exactly what's going to happen. The constructor game, or the constructor for game item, is going to be run.
That's right. And remember, a few minutes ago in the rules, what did I say? I said that there was always a constructor. Always. So if you do not put one in game item or whatever class it is that you're working with, the compiler will recognize that and add a default parameterless constructor itself so that when you use new and the constructor name, the constructor is truly there in the IL code. Okay, so it can find it, instantiate the class, and return the reference to that class. And that reference then gets stored in our variable of that particular class type. That's the big picture. That's how it all works. It's so simple. So this whole time, you've been calling constructors. Every single time you've been instantiating a class, you make a call to that constructor. And now you can see it. You can see it plain as day now that I've drawn an arrow from the call to the actual constructor that's being explicitly defined in this particular case. So this is really straightforward. Logan, let's jump over into Visual Studio. Let's create this exact thing and make a call to it real quick. Just show them that the console will write out that it's there. So let's go ahead and start a new console app.
Okay. Make a console application, and let's see, what do you want to do
Let's
first?
just do a class game item.
All right, we've got a class game item, and it has an E in it. All right, there's our class game item.
And inside it, let's go ahead and define a constructor.
All right, let's do this as a public game item.
Oops, there we go.
Yay. All right, and then our opening and closing parentheses.
All right, now let's go ahead and block her in. And let's do a console.writeLine and say game item created, or game item object created.
All right, game item object created.
Fantastic. Now let's go up to main and actually instantiate the game item class and then do a read line to halt execution temporarily.
Okay. Well, the variable we'll use will be of type game item. Do you want to call it player?
Yeah, we'll call it player just so it matches the quick example I did on the whiteboard.
So we'll say we're making a player game item. And we'll set that to be a new game item, and then of course our opening closing parentheses.
Okay. And then let's go ahead and do a console.readline.
Console.readline.
Beautiful. Now at this point, think about this. We have not turned around and said player.gameItem. We haven't done an explicit call here. Have we? Yes, we have. We've actually called upon the constructor to execute right here. This is just a unique situation. You get to see the constructor. Through all of the examples we've been creating, with the exception of 1 or 2 in the last section, the constructors have always been invisible to you. But now we have explicitly defined one and put some code inside of it. So every time game item is instantiated, the constructor is executed, and every time it's created, you're going to see game item object created. So Logan, let's go ahead and build and execute.
All right, we'll build. Everything succeeded. If we execute, we get
game item object created. So there you go. It's exactly what I just said. The constructor did indeed get called. Anything you want to add to this, Logan?
Only that with constructors, the parentheses in conjunction with a new of anything starts to make more sense. Since this is going to end up calling the constructor, and it's like, okay, well, we're calling upon functionality. So that's a beginning explanation for why we have parentheses along everything that we use with new.
That's right. Let's go ahead and expand upon the whole parenthesis thing right now. So let's go ahead and jump back over here into the whiteboard. What did I say earlier was the primary purpose of a constructor, outside of, well, instantiating the particular class? The primary purpose in regards to the programmer is to give you a place where you can go ahead and set the state of the object that's being created. So, in this particular case, we're not setting a state. All we're doing is writing something out to the console. So let's take this a little bit further. Let us actually do that. Let's go ahead. Watch this. Here's my idea. I should have moved this up a little bit higher. This will all make great sense in just a second. So if we come up here a little bit higher and we do a class game item, and then we do our opening, and then let's say that we had a public integer, so a data member. So public int called health. Actually, you know what, Logan? I'm going to make this even better. I don't want it to be public. I want it to be private. Yeah. Now, we have talked about what private means, left, right, up, down. You should have a clear understanding by now that private means that health is accessible within this class. It's private to this class. So we need some way of initializing the health. Well, what if we were to come in here and do something like this? Add parameters into game item. So if in here I was to say int health. Now I've created an interesting situation. I have two healths. I have a parameter called health, and I have a data member called health. Ooh, very interesting. Check this out. This is going to be your first true exposure to the this keyword. And it really is this simple. I need to be able to tell the application which health I'm talking about. I want to set the data member's health with the data that was just passed into the constructor. All I got to do is say this dot health equals health. Terminate. So what does that mean? Well, this, anytime you're using the this keyword, you are referring to the current instance of the class, meaning that you're referring to the current object, okay? So I'm saying in the current object that we're actually executing this code in right now, set its health, that means it's the data member, this guy up here, set that health to, and now the scope of health, so this parameter coming in has local scope within game items. So anytime you refer to just health, well, it hides the data member. But by saying this dot health, this exposes that health data member to us because we've used the this keyword. So we're now saying the object's health data member is equal to the parameter health. So whatever information was just sent into health. So now, when doing this line right here, we would have to expand upon it by sending in a value. So let's say that when we created a player, we're going to set its health to 100. We must send in a matching argument list. We must have the same arguments and their types must match as what is being accepted by the definition of the constructor itself, by the signature of the constructor. And it's looking for what? One integer, right? One integer, which is, of course, going to be called health. That's our parameter. So what am I doing? I am sending it one integer, a value of 100. What's an integer? It's a whole number, and I'm sending it a whole number right there. So this will allow us to set the state of player such that its health is initialized to a value of 100. There's the beauty of the constructor in action. Then afterwards, Logan, if you want to, actually, you know what, we could take it a step further, and you could just write out, you know what, no, I like this idea. Here, I'm just kind of making this up as we go along, but it's good stuff. How about go ahead and create a show health property, a public show health, because then you could turn around and say player.showHealth, and it could do a write line and show what the health is, so that we can show them that it is indeed initialized.
Sure.
All right, let's go ahead and jump back over and do this.
All right. Let's begin with game item, and let's add the health field to game item. So this is going to be a private field of type integer called health.
Okay.
The next thing we want to do is address the constructor and change the constructor so that it accepts parameters. To be more specific, the integer parameter. This is going to be int health.
Now, we have, all right, go ahead and finish off. We've just created a problem with the code the way it is right now.
Do you want to take out the right line or leave that in for now?
Leave it in for now. You can just put it under, above, it doesn't matter.
Okay. Now, the problem that we've run into is that this parameter health has hidden the field health in game item.
Right.
Which means that if we want to actually refer to game item from within this constructor, we have to refer to it through the class.
That's
because
right.
Health by itself is going to mean this parameter. So if we wanted to do that, of course, we use the this keyword referring to this instance of the class, which has the field health, and we can set that to the parameter health. So now the incoming health in this parameter gets set as the field for the game item.
And you can actually show them that if you do the mouse over. Well, with it, there we go.
And then we've got game item dot health.
Game items dot health as opposed to just the local health. Okay, very cool. So now we have initialized that data. Remember, let's go ahead and add a public method down below. Now, I don't want to change that yet up there. So let's go and add a public void show health.
Okay. So be public void show health. And inside of show health, we'll do a console write line. We will say
health equals,
and then append the actual health field. And here's something interesting. At this point, we can use health without referring to this if we wanted to, because there is no parameter that hides it. Health in this scope means the field GameItem.health. Now, by practice, it's certainly not a bad practice to start using this to refer to fields, because that way, that would mean that this line of code would not break if we suddenly started feeding it a parameter.
That's true, called health.
So, I mean, it could be considered good practice to, in this case, even though health is not hidden, we can still access it using this.health, because if we mean for this line of code to always refer to the field health, we can go ahead and put this.health in, because obviously that works straight out, because this does indeed still have health.
Right.
And if health were to suddenly otherwise appear as a field or a local variable, or excuse me, a parameter or a local variable, we wouldn't have any issues. It wouldn't suddenly hide the one we're trying to use.
Exactly. Now, before you run this, I'd like to talk about the problem that was just created. By Logan going in there and putting in his own constructor, we have now caused the compiler not to put in a default constructor. All right, that's all fine and dandy. I said that a few minutes ago. But now, if later in code you decide to call upon the creation of a new object in this particular manner, we're going to have a problem, because now there's not a default constructor, meaning a parameterless constructor. So what will happen is it's going to basically tell you, because, in fact, we're not even going to be able to compile, because the problem is we have to call upon game item right now with a integer being sent to it. So go ahead and try building real quick, just to demonstrate.
If we try to build, then we get an error on this line saying that there is no overloaded method game item that takes in 0 arguments.
That's right. Now, if the compiler was sweet enough to throw a default constructor in there, then there would be an overloaded method. That means a method with the same name that does not have any parameters. It has a different signature than the other method. But in this particular, I'm using the word method, but of course we're discussing constructors. I'm just saying they're using the word method down here. Ta-da! So now, let's go ahead and put a value in there and show that it'll build fine. So we'll put 100 in. All right, and build. So it builds fine, but in just a minute I want to address what happens if we do want the ability to call either way. So, but first of all, with this, if we execute it right now, the only thing that we're going to see is game item object created, because we have not made a call to show health. Let's go ahead and run it real quick.
Okay. So if we run, we see that it's created, but we see nothing else.
That's right. But the health has indeed been set. Let's go ahead and prove that now by closing that out. And after we instantiate the class, let's go ahead and call upon the player's show health.
So we'll tell player to show health. And there we go.
And now let's run it. And check it out. Game item object created, the health is 100. So the 100 we sent into the constructor was used to initialize the state of the player when the player was created. And to prove this, just since everybody thinks, well, maybe health is always 100 when it gets created, close that and change it, send another value. Send, say, 75.
All right. If we feed in 75 and run.
And health is 75. All right, so we can now see that the constructor is working in our favor the way we would normally use it, which is for initializing data members inside. All right, let's go ahead and close that, Logan.
Okay.
Now, of course, please keep in mind, we can obviously send multiple things. If Logan wanted to, he could come down here and create a private name, and then up here, well, let's do that real quick. I just want them to see sending multiple parameters.
Sure.
So private
if we make a
string
private
name.
Field string called name, and then change our constructor now to add or to take in another parameter. So we'll do comma string name.
Okay.
Now if we just okay, let me finish this off before I try to build. Let's make sure that we turn around inside the constructor and set our name field to be equal to the given name parameter, just like we did with health. Now if we try to build,
we run
new
into
game
the
item
same problem.
is once again an error because there is no constructor that takes in only one. The only constructor now takes in 2 parameters.
So let's go ahead. The big thing I wanted to demonstrate here is that we could send in as much information as we would like. Just we need to make sure that we separate each of our parameter types with a comma, just like we saw when creating methods. Let's go ahead and go up there and throw comma Bob or something.
All right.
So now we're going to make them as Bob. If Logan builds now, you'll notice that the build is error-free. And down in show health, let's just go ahead and print out the name too.
Sure. I'll just steal this line, copy and say that name equals this dot name.
And let's run it. And there you go. Health is 75 and the player's name is Bob. So you can see how we can easily send multiple things to the constructor.
So in that way, a constructor could be tailored to that specific class to work very well with exactly what you need to initialize or set up in that class.
Exactly. Now, let's make things a little bit more interesting. Let's start talking about constructor overloading. Let us say that for some reason I want to be able to say game item whatever equals new game item. I don't want to send it stuff. I just want to do that. So let's add another constructor now. So here comes constructor overloading. So for another constructor, we're going to do another public game item. So it will be the exact same name as the class, as I said in the rules, and then open parentheses, close parentheses, and now let's go ahead and do our opening and our closing. All right. So in here, do a console write line and just say default constructor called.
All right. Console.writeLine default constructor called. All right.
All right, good enough. Now, that is plenty. Here's what I want to demonstrate. remember, I had said previously what happens when a class is instantiated, all of the data members inside are set to their appropriate default values if they're not initialized, meaning that things like integers and floats and all are set to 0, where things like objects and all, strings, get set to null. So in this particular case, Logan, let's go ahead and create an enemy now of game item type and just use the default constructor, meaning the parameterless constructor.
Okay, so you want to jump below the player and just start a new game item.
Yeah, sounds good to me.
Alright, if we make a new game item called enemy, we could set that to new game item, this time with empty parameters.
And if Logan builds, watch this, it'll be real happy. Yay, it's nice and happy, because we have gone in there and explicitly defined a default constructor instead of hoping the compiler would put one in there, which of course the compiler would not, because it has recognized the fact that you have already created one. So now we've defined an overloaded constructor. We've added our own default constructor. But let's think about this. This default constructor doesn't contain any initialization type code, so we've got an interesting dilemma. We've kind of broke the logic of how game item works. Game item has been designed in such a way that it is expecting to initialize both the health and the name of the object when it is instantiated. But now we have the ability to instantiate game item and not have health and a name set. Let's demonstrate that, Logan, by calling the enemies show health.
Okay. So if we turn around and call upon enemy.showHealth and try to run.
Check it out. This is what I was talking about. So health 75 and Bob, and then down here health has been set to 0 and our name is set to nothing, okay? Because we haven't initialized these. So the standard default initialization took place when, of course, the object was instantiated. So now let us introduce initializers. So let's go ahead and close this. Hopefully with this point everybody sees that we can, for overloading, we can add as many constructors of the same type, with as many constructors as we'd like. What I'm getting at is they just have to have the same name. The key thing is, of course, the argument signature must be different for all of these, okay? With the signature being different, then of course, what do we have? An overloaded constructor, and the constructor that gets called is simply determined by the arguments you're trying to pass to it outside of that class, when you're trying to instantiate the class.
It's like a method overloading.
It's exactly like a method overloading. Okay, so as a matter of fact, as long as you think about constructors as methods that just automatically get called and they don't have a return type, then you're in good shape. Okay, so let's go ahead and jump back to the whiteboard real quick. And that's kind of, it looks like some type of grand plan or something. Let's go ahead and hide this for just a minute, bring this back. So we'll start to knock some of these things off the board. At this point, we have taken a look at, did I manage to successfully, hang on, if I come over here and add, add that, there we go. If I come over here and mark this off, so what are constructors? We've talked about them. Syntax, we've looked at it, and it looks just like the syntax for a method minus a return type, and add the initializer, optional initializer. Now, for types of constructors, we've been talking about the instance constructor, meaning that it's basically a constructor for a class that can be instantiated. So every time that class is instantiated, we have that constructor automatically called. We have taken a look at passing parameters to the constructor. We have taken a look at constructor overloading. Look how easy this is. Man, we're just flying through it. This is good stuff. But now we need to take a look at these initializers. Now let's jump back up to our syntax real quick. Our initializers are located over here. They're optional. And I said down here that we can see one of two kinds of initializers that are going to be used. You've got base and you've got this. Now what do these mean? Base means we're going to make a call to the constructor in the base class, the class in which we have derived from. We will get into that when we get into inheritance. Again, that's a situation where we need inheritance. Remember, I said the word would pop up. This, on the other hand, is our ability to call another constructor from a constructor within the same class. Remember, what did we say this was? It deals with that particular instance. So within the instance of the class, we're calling it, or we're in a constructor, let's call another constructor that's in that instance. So that's what we're going to take a look at. The colon this, and then you'll notice there's an argument list. And we have set ourselves up for a fantastic example back over here. Let's take a look at this. Right now, we have the ability to create, let me scroll down just a little bit and get everything else out of the way. There we go. So we're just looking at our two constructors. We have the ability to instantiate a game item class in two ways. One, with nothing initialized, so everything's just set to 0 and null, or with setting the health and a name. How about this? If we used an initializer, we could make it such that we always initialize the health to a predefined value, and we always initialize the name to a predefined value. That way, we can create a game item externally just by calling the default parameter, and we will have safe values set. So let's say, for instance, that if I don't specify a particular health, that the health will always be 100. That kind of makes sense.
Sure.
And if I don't specify a name, how about we specify not set? Because then we can always query that, and it'd be like, oh, what's the name? Oh, it's not set. Oh, that's not good. So we can do that. Check this out. This is where things get really interesting. Remember, what we're focusing on right now is what happens if we instantiate the class by calling the default game item. But we want these things set. Well, it's real simple. What if, when calling the default constructor, we tell it to first call this particular overloaded constructor, and we send it a default health and name? All of this takes place. Then we run the code that's inside the regular default constructor. All Logan needs to do right now is on the constructor is add the initializer, this, and send the appropriate data. So he puts the optional colon, and now he puts the keyword this. So that means call another constructor inside this class with the following signature. So in case we have a whole bunch out there. In fact, we've got two. Check it out. IntelliSense is being fantastic for us. It is showing us right here that we've got two overloaded constructors. Which one do you want? The one that does not take any parameters, or, go down, the one that takes in these two parameters? Well, we can't call the one that takes none, because you'd have a recursive situation where the constructor would call itself, but, well, that's just a problem. You can see that already. So what we need to do is call this constructor, but in order to call this constructor, we must pass it an integer and a string in that order for it to satisfy the requirements of figuring out what overloaded constructor to call. So let's go ahead and send it 100, comma, and in quotes we'll put not set. Now, the way the initializer works, this is all Logan had to do. The way the initializer works is if this constructor gets called, which it will when we're using a default constructor call, which has taken place on this line right here, default constructor call, there's no parameters. So that being the case, what happens is when this constructor gets called, it notices that there is an initializer. It goes, oh, we've got to do this first. So now we get execution passed down here to this constructor, and we have passed 100 into the local parameter health, and we have passed not set into the local parameter name. Now we can turn in here, and we're actually going to print out game item object created. Yay! Health. Well, it's going to get initialized. Name, it's going to get initialized. Then we're going to return back up here, and at that point, we can then do the code within this constructor, and then we're done with the instantiation of the object. Okay, I mean, we're done with all of it, all of the setup, if you will. So, Logan, is there anything you want to add to this before we demonstrate it?
No, I think we should go ahead and take a look at it.
So when we run it, keep in mind, right now, we're going to create the player, and he's going to be kind of healthy, 75 health points, and he's going to be called Bob. Our enemy, on the other hand, is going to be very healthy. He's going to have 100 health, and he's going to have a name of not set because we have yet to set the name. So let's go ahead and build and execute.
All right, we can build, and the build succeeded, so we'll run.
And check it out. Exactly as I described. Game item object created health 75 name Bob. That's the three things dealing with the creation of player. Now the creation of enemy, we get to see two write lines. We get to see game item, object created, and default constructor called. Game item, object created is down here in the first constructor that gets called because of the initializer. Initializer sends us down here, and that is why you see this line printed out first. Once we're done with initialization, like I said, we then come up here and actually execute the code within the first constructor, which is default constructor called. That's why you first see game item, object created, then default constructor. Let's go ahead and pull that back up. Called. Game object created, default constructor called. Then, of course, we print out our health. What is it? It's 100. We print out our name. What is it? Not set. Just like I said. This is using an initializer. It is simply the means of which you can call another constructor within the class, or again, we can use base. So with base, if we had inherited this class from another class, from a base class, we could have said base and sent it information, meaning call the constructor in the base class sending this information so that its state gets set accordingly. And again, we're going to talk about that when we get into the inheritance video. Okay? Logan, is there anything you want to add to initializers?
Just that it's the way the initializer works makes this very handy for any case when you have some things that need to happen within one of the constructors that takes in parameters. For example, if these lines of code are critical to the working of the GameItem class, yet we also want to allow a default constructor to be available for the class, an initializer becomes very useful because we can make sure that all of our critical code in the constructor with parameters is called while still allowing a default constructor to be called.
Exactly.
So that way we can have simple construction outside of the class while still ensuring that everything is called thanks to the initializer.
That's right. All right. I think between that and the demonstration, that should be pretty clear. Okay? So let us jump back over to the whiteboard. Every time I come back over here, this screen just scares me. Let's go back to this one for a minute. All right. So now we've talked about, let's put our focus down here. And no, I don't want to rename the level, or the layer, but thank you. So now that we've talked about constructor initializers, let's go ahead and talk about modifiers real quick, which will bring us into a discussion of private constructors. So what modifiers do we have available? Well, we've been using public. There's private. There's protected. There's internal. And then, of course, this is a combination of modifiers, but there is protected, internal. All right, here's the deal. We've talked about public. You've seen it. Just your regular run-of-the-mill instance constructor. Internal, same thing, okay, except for we're locked to the assembly. So no need to even cover it. We've talked about internal many times. Protected and protected internal, now we have to start getting into inheritance again. That's coming up a little bit later. So these things will be discussed later. That leaves us with private. And by the way, these of course are access modifiers. We also have as a modifier static. That we'll be taking a look at in a few minutes as well. So these are the two big things left we need to look at. When using a private modifier, what happens to the constructor? And then when using a static modifier, what happens to the constructor? All right, so with that, now once again, protected and protected internal. Well, protected internal, you could use it right now in the assembly, and it's, well, going to act just like public or internal because everybody within the assembly can access it. But once we start dealing with other assemblies, then we're starting to deal with the world of inheritance again. So we'll get back to all that stuff later, so just keep that in mind. All right, now, let's go ahead and jump back in here, add another page. And on this page, so make life a little bit easier, let's start off by talking about private constructors. So let's jot that down. Once again, ladies and gentlemen, get ready to use your trackbar because there are a few things I'd like to write down for you. So first of all, a private constructor is a special instance constructor, as I said a few minutes ago at the beginning of this video. It is commonly used in classes that contain static members only. Why is that? Well, let me just write the rules down. This will help define everything. The biggest thing is a class with private constructors only, meaning there is no public constructor in there. The class cannot be instantiated. So cannot be hey, like I got real quiet. That required every bit of my thinking power to make sure I spelled that right. The class cannot be instantiated if there are only private constructors inside of it. That means you cannot make an object. Kind of sounds like a static class or an abstract class. Yes, but there are definite differences. We can instantiate this class inside this class. Oh boy, I bet that just blew a mind or two. Don't worry, we'll come back to that in just a minute, and we'll touch on it lightly, even with an example. I don't want to really get into factory method design principles, but we're going to start just kind of touching on factory methods here, where this class itself will be responsible for deriving an instantiation of itself and passing that control back out for someone else to use, which is really neat stuff. We'll make a very simple scenario of that in this video. But with private constructors only, it cannot be instantiated. Next thing, a class with only private constructors cannot be inherited from. Oops. So the moment we put a public constructor in a class, and again, there's no, a private constructor, there's no public constructors. The moment we put a private constructor in a class, you cannot turn around and derive from that class. We've just locked it, okay? Can't instantiate from it, can't inherit from it. All right, the instance of the class can be created in the class. That is really important, as I was saying a second ago. So we can create an instance of ourselves inside ourselves. Ooh, yeah. Okay, and trust me, there's a lot of power to that. There are some really cool benefits of being able to do that. Now, I got a note for you. If all methods, and this is from Microsoft, and this makes a lot of sense. If all methods within the class are static, go ahead and consider just making the class static, okay? Because in this particular case, why would we have a private constructor as opposed to having a static class? Well, for the simple fact that we still have the ability to instantiate the class from inside the class. With a static class, it can't be instantiated, period. Well, the moment we've made all of our methods static, what could you instantiate the class for? It has no behavior that would carry over to an instantiation, because static members belong to the class, not an instance of the class. So that means an instance would be, well, nothing. There's useless. So that is a very important concept to keep in mind. If everything inside your class ends up being static, there's no reason to have a private constructor. Just make your class a static class, okay? And we'll start talking about static constructors, and you'll see how you can use a static constructor to go about initializing all of your static fields. And we'll get to that in a few minutes. So that is an important note. Now, let's go ahead and come up with some sort of quick example. Let's see. Do I have some room to write with? If I hide this and... because I want to draw this out if you guys don't mind, and then we will discuss it in great detail. So we'll start out right about here. Looks good. So we'll pick on the same thing that we've been picking on. Class, game item. All right, now for the class body. Here we are, a unique situation. We have to, once again, use static. Okay, in this particular case, we are going to use a static, well, we're going to use, but you'll see. Hang on. Let me just go ahead and start writing this out. I'm going to create a public. See, it's like, what comes first? The static members lesson or the constructors lesson? A public static. Now I am going to create a method that is going to return a game item. And it's called make game item. Okay, so here I am defining a static method. Now, I'll get back to putting some guts in it in just a second. Now I'm going to create a private, well, if I can spell it right, private constructor. That means it's going to have the modifier private, and of course we must have the same name as the class. And this. And for demonstration purposes, let's go ahead and put a public method in here that returns nothing called show text, just to show some text. And inside here, we're going to wave at the world. So we'll write out, how about we'll write out hello world. And then that will be the end of class body. Now let's go ahead and bring our attention back up here to this area. Now our discussion is this, private constructors. But we're going to set up a class here that functions in a very unique way. So here, public static game item make game item. Let's break this down. All we're doing is creating a very simple method called game item. It takes in no parameters. It returns a game item object back. That's interesting. We're inside a game item. So what would the return line look like? Well, let's finish the code. Return. Now, new game item. Open and close parentheses. Now here I go using the keyword new, and I'm calling upon a constructor. It is a private constructor. In fact, there he is right there. But this constructor, this is all internal. It's all inside the class. All these guys can see each other because they're all in the same room together. So I'm calling upon a new game item. Now I have that game item. I have a reference pointing to that game item. I return that. Okay? Once I return that back out, back on the outside world, I receive a game item, or a reference to a game item, and I'm now pointing to the instance of this object that I just created. And then I could turn around and say, you know, whatever the reference name is going to be, let's say it's player. I could say player.showText, and I now can gain access into this just fine because it's public and I'm able to. And it would write out hello world. So this right here is a factory method. We're actually creating this object from inside the class and then passing kind of like a handle back to the outside world for someone else to take control of the object. Does that make sense, Logan?
Right, and all at the same time giving us more control over the actual creation of the game item.
Oh, without
Unlike a constructor, because a constructor doesn't have a specified return type. A constructor deals in the type that it resides in. If a constructor is inside of game item, it is going to deal only with making a new game item, nothing else. It doesn't have the option of simply not making a game item. That's not allowed. When you're in the constructor for a game item is going to be made and returned.
Exactly.
In this,
go ahead.
In this factory method, make game item, there's no rule imposed upon that. We could set it up so that it returned null if we wanted to.
Mm-hmm.
We could run make game item. We could do a check. Let's say we had a mechanism for tracking game items. We could see if there are too many game items, and if so, fail out and not return a game item. We could even change the return type to be integer or boolean.
Or return a null and check to see if we got a null back.
Exactly. So we have more options at that point. We have control over whether or not it's actually created. Whereas if you're dealing with a constructor, you're dealing with a new instance that just got created.
Yeah, you're talking about just a regular run-of-the-mill instance constructor. Yeah, you have no control there because the bottom line is, ta-da, it's made. I mean, that's what the constructor's going to do. All you can do is initialize stuff in there. So like Logan says, and that's an excellent point to make, we have a lot of control by doing this particular method. We could actually stop the creation of the game item if we wanted to, based on any kind of criteria that we set up. Now, how would we use this on the outside world? Well, it's real simple. Let's just stipulate that up here I'm coding inside of main or somewhere else. All I would need to do is say game item, and we'll pick on player since we've been doing that. I need my variable that's going to hold the reference. Now equals, check it out, this is where things get very interesting. Instead of saying new game item, we can't do that. Why? Because it has a private constructor. There are no public constructors. As a quick side note, I can add a public constructor into the game item class and have a private constructor, and the moment I do that, then what happens is I can indeed instantiate the class. But I cannot have a public constructor and a private constructor that are both parameterless. That's a big no-no. You can't do that because, well, you just can't.
Because inside the class, there would be an ambiguity between those two.
Without a doubt.
The compiler and the CLR would not be able to tell the difference between the public and the private because inside of the class, you can see both, and there's no argument signature to tell them apart.
Exactly. Well, there is an argument signature. It's parameterless. It's empty.
Right, and then there's your ambiguity. You can't tell the difference.
Exactly. So how do we go about creating one of these? Well, in this particular case, we'd call the class itself game. Go ahead, Logan.
Sorry, just because we need to access make game item.
That's right.
Since we're not using
which
new.
is static. That's the key thing here. That's why I'm allowed to do this. I can say game item dot make game item. Got to write small, guys. Bloop, bloop. There we go. That's make game item. So let's just all agree on that. So this right here makes a call into this method. Inside this method, currently what we're doing is returning. We're creating a new game item. So he gets created on the heap. So let's pretend here's our heap. Okay, and here is the class game item. So I'll just say game item. So now we get a new instance of game item. That, of course, points back to its class object type. So here's a new instance of it. And then we return the reference from it back to, well, our caller. Because remember, there is a return type for this method, a return type of game item. What is that? It's, well, a reference type. So we send that reference back. So now player, which is sitting over here on the stack. So let's just stipulate there's all sorts of stuff going on the stack. But this is player. All right, I just wrote the word player. He just receives that reference back, so he's now pointing to this new guy. Now I can turn around and say player dot, and I can say show text, and I can call upon this, which is internal to the player without any problem.
Sure,
okay?
Because it's public.
Because it's public, that's right. So this is what, Logan, let's take a minute and create this. And we can actually have some fun with this. We can demonstrate how we cannot just outright instantiate the game item class.
Right.
Because it is, well, of containing only a private constructor.
Well, let's jump over to Visual Studio now. And I'm going to start a new solution.
Sounds good.
Entirely new project. We'll discard this old one. This will also be a console application. All right, let's begin on this game item.
Okay. So regular class of game item.
Item. And the first thing that we're going to have in game item, do you want to start with the static factory method?
Yeah, we'll just write it down exactly how it was over on the board.
All right. We'll make this a public static method returning a game item, and it's going to be called make game item, and take in no parameters. Which inside of it, we're going to return a new game item, and there we go. All right, now
a private constructor.
This will be private game item, open closing parenthesis, and there we have a private constructor.
And we're not even going to put anything in it. Nothing at all. Just the fact that it's there in private. We lock this class down since there are no public or no internal constructors sitting out there. Since it only contains private, we've just locked this class from being instantiated externally.
The reason we've locked that is because since this is indeed a constructor that we've placed here, the compiler is no longer going to drop its own default constructor.
That's right.
So therefore we lose that public default constructor.
And since this thing is called private, externally, we can't see it. And if you can't see the constructor, you can instantiate it. Okay? So let's go ahead and add just a quick public void show text.
All right. Public void show text, which when called will write out to the console, and it will say just maybe hello world.
Yeah, hello world. All right, beautiful. Now let's go ahead and build real quick just to make sure we have no problems. All right, now let's go ahead and go back up to main. And from inside main, first of all, let's go ahead and create a game item player.
All right.
And let's try using the old-fashioned, equals new game item.
All right, new game item.
And then let's go ahead and throw in the player.showText.
Sure. Say player.showText.
And then let's go ahead and prepare with the read line.
All right, and then we'll throw in a read line. And there we go.
All right, so if everything that we've said so far in this lecture is true, this right here is making a call to what is expected to be some sort of public constructor. And we know there's not one. It's only been marked as private, so we can't see it. So this should actually generate a problem when we try to build the solution. Let's go and try it.
All right.
And what do you know? That game item is inaccessible due to its protection level. Because the constructor is private, we cannot instantiate the class. We cannot make an instance of the class this way, but we can make an instance of the class. We just have to do it a new way, and a way that gives us a lot more flexibility and power, like Logan said a few minutes ago. Let's go ahead and show them a call straight to game item.
Okay. So game item
dot. Now we can see all of our static members in here, and we've got make game item. So in an open closing, there we go. And now at this point, we'll go and build first, just to show all errors are gone. So the build was successful. This is simply saying, all right, let's call on the static method make game item. Static method make game item returns a game item. Oh, how convenient. We need to store a game item. So what are we going to return? Well, we're just simply going to create a new game item. So that reference gets returned back to player. So now player is pointing to an instance of this class. But at that point, we can access all of our public stuff inside of it. So we can access show text. So as you saw a second ago, Logan built and the build was successful, which means if we run it now, we're not only going to be able to generate a player, but we're also going to be able to show the text in the player. We're going to be able to say hello world. Let's go ahead and run it and demonstrate.
Okay. If we run, there we have hello world.
Hello world. It worked. So again, you may be sitting there looking at this going, okay, guys, this is just a little bit confusing. I don't really get it. And if you don't get it, that's okay. You can watch the video again, and as we dive deeper and deeper into this volume, these things are going to make more and more sense. But what have you done here? You have created a very unique situation for yourself where you can decide if you want to or do not want to instantiate the class. Before, with the regular public constructor call, the class is instantiated. The object gets created. You don't have that control. But in this particular case, you can decide to return null or return a new game item. And you can have your logic inside this method to determine if that needs to happen or not. There's all sorts of things you can do. I mean, that's just one example of many things you can do with this type of a setup. But this gets into factory methods. I mean, that's what we're doing. Within the class itself, we're instantiating ourselves. We're pumping out items of ourself, if you will. Okay? Anything else that you want to add to this, Logan, before I move on?
No, I think that pretty much covers it.
All right. Well, let's go ahead and jump back over here. That is everything that I wanted to demonstrate with private constructors. So let me go ahead and bring this guy up and hide. Bring this up. So now we have looked at private constructors. And we've also looked at modifiers. So we can mark down, wow, we're all the way down to just one thing. And with this last thing, it's a very unique scenario. Do we show it now or do we wait a few minutes until we get into the static members section? I say we go ahead and simply show it now. So a static constructor is a very unique kind of constructor. Let's go ahead and set ourselves up another whiteboard that we can write on. And then let's hide out this one. And let's go ahead and jot up here, static constructor. Actually, we'll say constructors. And my horrible line. Ooh, actually, that was pretty good this time. All right, a static constructor is used to initialize, well, static data members. It is called, now here's the tricky part. Follow me carefully. It is called automatically before the first instance is created or any static members are referenced. That is the important thing to understand. It is something that gets called the very first time something touches the class. Okay? Meaning an instantiation occurs, meaning we're going to automatically set some sort of static data member inside. The moment we touch that class, boom, then it is called and we can initialize things within. So let's talk about some of the rules with a static constructor. Starting off with, it cannot have accessibility modifiers. No accessibility modifiers. The constructor is just automatically going to make this private. Next, it cannot have parameters. Ooh, there's a big difference between both the private and the other guy that we were looking at, the instance. So cannot have parameters.
Which makes sense, seeing as how you can't directly call it.
That's right. Which obviously, this one should be obvious, but I'm going to throw it down as a rule. Since it cannot have parameters, it cannot, let's all say it together, be overloaded. Remember, what's overloaded? It's when you have multiple constructors that have different argument signatures or different parameter signatures. If we can't accept parameters, how could you have different signatures? So we can't overload it. All right. It cannot be called explicitly. And then finally, it cannot call other constructors. So there is no using an initializer with this. We can't call this and we can't call base. Static constructor, man, it's no joke. It means business. It's just in there. It's streamlined. It is the first time you actually touch the class, be it an instantiation of the class that you're about to do. Because we're not saying the class is static. The class could still be instantiated all day long. We're just saying that it has this static constructor in it that's going to make sure some initializations occur before any usage of the class actually takes place. But the constructor, the static constructor, does not actually get called until you touch the class. Meaning that all because we have a class in our code and compile and run, that does not mean the static constructor automatically fires when it runs. No. If it does, that means we'd have data set up and everything else that would automatically take place on the heap. And wouldn't that be, well, less than efficient if for whatever reason we never instantiate the class or we never use the class? Yeah, it would be a waste of memory. So basically, it's just going to sit there, and when you touch something for the first time, as soon as it realizes you're about to make that access, an instantiation or the initialization of a static member or something, then the static constructor goes, aha, fire, and then it fires. Okay, and it's, of course, a one-time deal. So here's some rules. Let's see if we can give some sort of example. So if we were to come down, and once again we were to create a class, game item, and then inside game item, since of course we're dealing with static, boy, the next video should go real quick, Logan, when we start talking about static members, because we've covered it so much. Let's go ahead and create a public static integer called count. Okay? And let's say that we want him initialized for whatever reason. Now let's create a static constructor. Notice how I did not say public static. We can't do that. You can't have an accessibility modifier. So static, and of course same rules apply, game item. Now our rules get a lot more strict. We cannot have parameters in here. We cannot call an initializer. And then inside here, let's just, Logan, when you go to do this, let's write out, something like in static constructor. But inside here, we could go ahead and set count to some value. I'll set it to 0. No, I'll set it to 10. Count sets to 10 just because it runs. Why am I doing that? Well, because it gets set to 0 automatically. So for whatever reason, our game item needs a count of 10 the very first time the class is ever touched, just to give it purpose. All right, so there we go. Now let's go ahead and create a public static void show text. So we can go about demonstrating the static constructor getting fired two different ways. So show text, open, close, and we'll write out hello world again. And we'll end this all off. So now the question is, what actually causes the constructor, the static constructor, game item, to fire? Well, it is the access of something. If back in main, so let's come up here and stipulate that we're inside of main right here. If we said basically write out, so console.writeLine, in main, well, if I could spell it, in main, woo, and run our application right now, we will not have this guy fire. It is pointless. If this was our entire application, why would we need to go ahead and set up a count data member and initialize it to 10? That is wasted memory. So we have not yet touched the game item class. Now, if we, for whatever reason, externally said, even after or before this, it doesn't matter. If we said game item dot count, notice how I'm addressing the class directly because these are static members. So game item dot count equals 0 or 1, or it doesn't matter. This line right here, what am I doing? I am actually utilizing the game item class. I'm touching it. I'm doing something to it. And what will happen is basically it's going to identify the fact that there is a static constructor, and it will fire that static constructor one time. Boom. And then, of course, anything else I want to do to game item, have a good time. The static constructor has fired. So that is one example. Another example, if let's just say we didn't have that particular line, game item.count, I could have done a call to the method. I could have said game item dot show text. And GameItem.showText, before we show the text, once again, it's going to recognize if, again, I'm stipulating that the line where we set the count just a second ago isn't there. So this is the first time right here that we actually touch the class. What's going to happen? It's going to go, oh, we're touching the class. First time ever. There is a static constructor. Fire the constructor. Do the stuff inside of it. Okay, now let's show the text. So in that particular scenario, you would actually see on the console, in static constructor, count would be set to 10, and then you would see, hello world, Okay? So that's the key thing to remember with a static constructor. They don't get fired until something in the class is touched. A static data member, you can instantiate the class if you want, whatever. But something has to be touched for it to get fired. Again, as I said, there are no accessibility modifiers allowed. You cannot take in parameters, which means you, of course, cannot overload it. You cannot call it explicitly the way that, like we've been calling new constructors earlier. We were calling explicitly the constructors. And then cannot call other constructors from inside. So we can't have an initializer. So Logan, let's make this real quick and just demonstrate this functionality over inside of Visual Studio.
Okay. Let's jump over and start a new project once again. And inside of this project, let's begin on the new game class.
All right.
Game item. This is, of course, class game item. And inside of game item, we have a few things. First, we have a public static integer called count. Next, we have the static constructor. So this will be static game item. And then open, close, and parenthesis. And there's our static constructor. Inside of that, we can go ahead and write out to the console. And we can say, write line, and say just something like in static constructor. Alright? And now finally, let's also have a public static method simply to show text. So this can be public static void show text. And inside of show text, all we're going to do is write out hello world. And
beautiful.
That's all we should need.
All right, so that's just like what we had back over on the whiteboard. Now let's go and proceed up to the main method. And inside here, let's just do a console.writeLine, in main, just to show that we are, well, inside main.
So, in main. All right.
All right, now let's do a read line, just to halt execution for a second so that everybody can see that we did not fire the static constructor. And I say that because you're not going to see on the console in static constructor being echoed out. So let's go ahead and build and execute. And there we go, in main. So the static constructor did not fire. So that's very interesting. The memory has not been allocated for count and all that good stuff. Let's go ahead and close this. Now watch this. Now let's touch something in it. Let's try to initialize count because count is public, so we can get to it. And it's static, so there's only one count. That means we get through it through game item. So we can say game item.count.
So game item.count, and let's set it to maybe 55.
Okay. Now, the very first thing that's going to happen is it's going to recognize that we are now trying to touch the game item class in some way. So that will cause the static constructor to fire, which means we're now going to see in static constructor. And, of course, count will then be initialized to 55, and then we're going to see in main. So we're going to see echoed back out on the console, in static constructor, in main. Let's go ahead and run it. Look at that. In static constructor, in main. Fantastic. And let's go ahead and comment out the setting the count, and let's just call the behavior.
Okay. So if instead we were to say something like GameItem.showText,
and this is really cool. Notice how Logan is actually calling the show text, right? This will demonstrate that it's going to recognize an execution that we're touching game item. Game item has a static constructor, so this is going to run before show text does. So it's going to write out in static constructor, then we'll do show text, hello world, then we'll return back out and do in main. So you're going to see in static constructor, hello world, in main. Let's run.
Okay.
In static constructor, hello world, and in main. There you go. So it is working exactly as we have described. Logan, is there anything you would like to add to this?
Just to point out to keep in mind that the point at which the static constructor gets called is, again, whenever a static member is accessed, which means we could still change the order of execution if we were to move the write line for in main back up to the beginning of the program and run this before we use anything in game item. We should now see in main before anything dealing with the static constructor or hello world. And there we go.
So it's again, it's the first time, as I was saying a second ago, that it recognizes that, yes, we are indeed going to use the game item class. So since we know we're going to use it now, fire off that static constructor.
And that's the biggest thing to keep in mind when using static constructors is just make sure that you don't confuse the time that it runs with the application loading time. If you use a static class very quickly, then it might look like, well, it's happening at program load.
It's part of the programming loading up.
But you have to keep in mind that that's only because you may be accessing something. If you were to move that code somewhere else, move that access point somewhere else, then you could run into a scenario where your program might run for some measurable amount of time before a certain static constructor is ever called at all.
That's right. Which, depending on how the logic of your code is laid out, could result in trouble.
That has two implications. Inside of a static constructor, it would generally be a good idea to only reference things that are inside this class.
That's right.
Because then the whole time problem isn't a problem. Because inside this class, if the class hasn't been loaded into the heap yet, then obviously we don't have anything to worry about.
Right.
And the other thing to keep in mind is just that if you have any type of time-sensitive code, if there is some functionality inside of a static constructor that can maybe look at the system clock and get the current time, just keep in mind that this static constructor may not run for a while if this class is not used for a while.
That's correct. All right, well, let's go ahead and jump back over here real quick. So that is static constructors. So let's see, how good of a job did we do in this video? Da-na-na. Man, not too bad. Let's go and hide all this for just a second and bring our attention back over here. All right, so that is, well, let's make sure we put ourselves on the right layer. All right, so that basically takes care of static constructors, and that brings us to the end of the video. A quick review, what are constructors? Well, constructors are special methods that belong to the class that get called at various points. It could be when the class is being instantiated. Of course, an instance constructor would get called. It could be when the class is being touched for the very first time or being used for the very first time. A static constructor gets called. And then, of course, we looked at the basic syntax. It looks just like a method with the exception of we don't have a return type and we do have the option of using an initializer. Now, from there, we took a look at the different types of constructors. We saw that technically there are two, instance constructors and static constructors, though private constructors almost rank up there in the area where you can say it's a type of constructor because it has a special kind of behavior, such that if it is the only constructor within a class, it prohibits that class from being inherited or instantiated.
Right, it changes the way that you have to go about using that class.
That's right. Then we took a look at passing parameters to constructors. Very simple stuff. It's exactly the same as passing data over to methods. Now, the key difference being if we turn around and use an initializer, well, you're going to be using the keyword base or this, and then we'll pass those parameters along or pass some sort of data along. We took a look at constructor overloading, exactly the same thing as when you're working with method overloading. There's just different parameter signatures. And then, of course, we've got constructor initializers, as I just said, the ability of a constructor to call another constructor within the same class or to call a constructor in a base class, and, of course, pass arguments to either, depending on who you're calling. And then finally, we looked at modifiers for just a second, where we talked about public, private, protected internal, and protected internal, as well as static, with our primary focus this time around being public, and you could say internal as well, because it's going to work the same except for lock to an assembly, and we looked at private, and we looked at static. So these guys have all been covered quite well, and protected internal really fall in the world of inheritance, which we'll be coming back to constructors once again when we get into inheritance, and really start pushing the idea of constructor chaining, which gets really interesting, though you've seen a little bit of chaining here, and that is just having one constructor call to another constructor. But that is going to wrap up this video on constructors, and hopefully you have at least a decent grasp as to what's going on. Remember, the key reason for them is to initialize the state of a particular object. Or you could even say initialize the state of the class itself if we're using a static constructor. And with that, that wraps up this video. Thanks a lot, guys.